Hi guys. So today we'll be solving a problem from Codeforces. So let's read the question. After the lessons end, groups of school children went outside and decided to visit Polycarpus to celebrate his birthday. We know that the ith group consists of SI friends and they want to go to Polycarpus together. They decided to get there by taxi. Each car can carry at most 4 passengers. What minimum number of cars will the children need if all members of each group should ride in the same taxi, but one taxi cannot take more than one group? So basically what this problem means is that there are n groups of people and each group has 1 to 4 members. These guys need to go somewhere in several taxis, and the thing is that each group needs to go in the same taxi. They cannot be in two different taxis. Each group needs to go in the same taxi. Okay, but one taxi can take more than one group. Like if there are groups of two groups of two people, these guys can go in one taxi. Okay, so that's the problem. Now let's look at the code for it. So here is the code, and yeah, so basically we have an integer t over here. That's an integer t, and we have integers a, b, c, and d. So a is for the number of groups with 4 people. Okay, I'm sorry, a is for a number of groups with 1 person. All right, and b is for the number of groups with 2 people. C is for the number of groups with 3 people, and D is for the number of groups with 4 people. Okay, all right. Now, okay, let's look at a case. The first group is for single group, so it'll be 1, right? So if it is 1, it'll go to A. If it is 2, it'll go to B, and if it is 3, it'll go to C, and if it is 4, it'll go to D. Okay, so by the end of that, you will get the number of groups according to the size. All right. Okay. Now let's look at this. So we have an integer taxi. This is for the total number of taxis that are required. Okay. And now first, let's take a group of 4. Okay. So if there is a group of 4 and each taxi can hold 4 people. So for every group, there needs to be, if there are D groups of 4, there needs to be D taxis, right? And all these taxis are full. So if there are I'm sorry, if there are D groups, we can add the total D to the total number of taxis, all right? So taxi plus D, okay? Now, I hope you understood till here. So now we will look at groups of 3. Okay. So when there are groups of 3, if there are C groups of 3s, there needs to be C taxis because each group needs their own taxi because they're groups of 3, right? So if there are like 2 groups of 3s, so each group will be going in their own taxi. All right. But in every taxi, there is one vacant space, right? Because there are only 3 people in a group. So for every taxi, there is one vacant space. And in this space, a single person can be fit in over here. A single person can squeeze in with the groups of 3. All right. So if there are C groups of 3s, C number of single people can fit in the taxi, right? Okay. So We add C to the number of taxis, okay? And the thing is, we subtract C from A because C single groups go along with the triple groups. So we subtract C from A, okay? And this is what we do. And if A is negative, we make it as 0, okay? All right, that's it. So now let's look at the groups of 2. And this is very simple. If there are even groups of 2, it is very simple, okay? Like suppose there are 4 groups of 2. 1, 2, 3, and 4. Okay. So these guys require one taxi for these two and another taxi for these two. All right. So the taxis are full. So if there are 4, you just divide it by 2 and you get 2 and you get the number of taxis. All right. So yeah, that's it. You divide B. If there are B number of taxis, you divide it by 2 and then you add that to the total number of taxis. Okay. Now, what if there are the number of taxis? What if the number of groups of 2 are odd? Then what will you do? So suppose there are 3 groups of 2. All right. There are 3 groups of 2. So these 2 groups can go in one single taxi. Okay. So one group and 2 groups. The taxi is filled. Now, what about the third group? The third group will take up half of the taxi. Okay. But there is still space for 2 more people. Okay. Just 2 more people. So we take these 2 more people from the number of single people. Okay. We squeeze in the 2 people along with the group of 3. Okay. So yeah, so we have you guys heard of ceiling function? Okay, so ceiling function is basically like if there are 3 people, if there are 3 groups and then you divide it by 2, you're supposed to be getting 1.5, right? But you take the greatest number. So you'll get 3 divided by 2 is 1.5, so you'll get 2. This is a ceiling function. All right. So you get the ceiling function and then you add it to the total number of taxis. Okay. Then you subtract 2 from A. You see these two people squeezed in with the third group, with the group of 3. Yeah. So you subtract 2 from A. Okay. That's it. And then if A is negative, you just make it 0. That's it. Okay. And now the last single groups. So sorry guys. Sorry again. Okay, fine. So now for the last group, if there are like say, if there are 5 groups of 1 people, 5 single guys, 4 of these guys can fit in one taxi and the last guy goes in another taxi. Okay. So 5 divided by 4, you get 1.25. Okay, 1 point something. You basically take the ceiling function of that and then you just get it as 2. Yeah, so that's it. And then you'll get the number of taxes for single guys. So you take that number and then you add it to the total number of taxis. And then, yeah, that's it. You get the total number of taxis required and then you print it out and you get the results. That's it.